first thing we're going to take a look at is just looking at the word trigonometry and kind of break it down and see what it means. So anybody recognize in that word part of maybe a prefix or a suffix? Is there anything there that somebody recognizes? Yeah, Dominic?
Doesn't TRI mean three?
Yeah, so try. Try means 3, right? So try means 3. I'm even going to extend it a little bit, gone. Anybody think of a word that ends in gone? Vivian?
Like pentagon.
Pentagon, hexagon, octagon. Gone means sided. You put a prefix in front of it, it tells you how many sided. 3-sided, 4-sided, 5-sided. So a trigon is just another name for a triangle. Right? So 3-sided. And then there's also this part at the end here, metri. Anybody know what metri means? Yep.
Is it the study of?
Study of is ology, like biology, study of life, things like that. The study of is ology. Metri is a little bit different. It kind of looks like the word a little bit that it means. Yep.
Is it measure of?
Yeah, measurement or measure of, yep. So really, what we're talking about in the class a lot is 3-sided measurement or measuring triangles. Like if you had the ground and a building and somebody over here, and let's say that they measured an angle to the top of that roof to be 40 degrees, and they knew they were standing 200 feet away from the building. How tall is the building? Well, basically involves measuring a triangle. Just like that. The base is 200 feet. The angle is 40. Assuming the building is perpendicular, that's 90. Solving for x would be measuring the height of the triangle, or really the height of the building in that case. So that's an example of a very, very simple right triangle trig problem. Gets a little bit more complicated than when we have triangles that are not right angles, but we can work with those too. All right. So any question on what the word trigonometry means? Measuring triangles. So, two things that we're gonna take a look at are what's called the distance and the midpoint formula. And the real reason for looking at those today is because the distance formula involves square roots. And square roots are something that are going to come up all year. Okay? And a couple things we have to know how to do, especially simplify square roots. So it's more of an algebra thing. That's not a trig thing. But I'm going to review it just to make sure people remember how to do that. So when you're given a distance formula problem, what they're going to do is they're going to give you 2 coordinates and ask you to find the distance between them. Okay? An actual problem, just to show you what it would look like, would look something like that. Find the distance between 4, 5 and 3, 2. So let me go back and show you what the formula is to do that. And this formula, it's going to be the first thing that we look at that fits the description of this class, measuring a triangle. This formula is all based on measuring a triangle. And so what I did down below is I just sketched those 2 points, A and B. It doesn't really matter where you put them. But the goal is to figure out that distance. How far is it from A to B? Now on a grid, it's very easy to measure if things are horizontal or vertical. So if I said, what's the distance between this point and this point? Well, that's easy. All you have to do is count. 1, 2, 3, 4, 5, 6. Same thing if it was horizontal. 1, 2, 3, 4, 5. The problem comes in when it's on an angle. You can't just count diagonally across squares. Right? And that's what this distance in this case is. It's on a diagonal. So in order to find that, what we're going to do is we're going to break it down into two distances that are easier to find. This distance, which is supposed to be vertical, and that distance. Now directly, that doesn't really help. That's not the distance between A and B. But this is easy to find. This is easy to find. In a triangle, if you know two sides, the third one is easy to get. And that's the one that we want. Does anyone know the name of the theorem that you can use if you know two sides of a triangle to find the length of the third one? Peter?
Pythagorean?
Yeah, the Pythagorean theorem. Very good. So once we know this and we know this, we use Pythagorean theorem, and that gets us what we really want to know. And that's the distance formula. So let's look at this one. And I'll make this green just to make it a different color. How would you find the distance from here to here? Or how would you find the distance between any two things? What math operation would you use to find out how far apart two things are? Yeah, Angelina?
It's the distance formula, like x2 minus x and y2 minus y.
So you said minus, right?
Yeah.
So yeah, if you want to know how far apart two things are, you have to subtract them. How far apart is the number 1 from the number 7? Well, do 7 minus 1 is 6. The distance between 1 and 7 is 6. If you want to know how far it is from here to here, you would have to subtract the x value of that coordinate that I just highlighted from the x value of that coordinate. And it's exactly what Angelina just said. This one over here is at x2. This one over here is at x1. If you subtract them, it'll tell you how far apart those two green dots are. The y's don't matter here. If you're looking for how long something is horizontally, the heights don't matter. The heights are the same. We're looking at the x-axis. So based on that, does anyone have a guess what the formula would be to find the length of that line in red? You're going to subtract two things. So basically, what's the height here? What's the height here? And subtract them. Yeah, Jess?
y2 minus y1.
It's y2 minus y1. Maybe this height is up at 7. This height is at 0. 7 minus 0 tells me the height of that line segment. So now we know the length of the bottom and we know the height. Does anyone remember what's the Pythagorean theorem? What is that, James?
A squared plus b squared equals c squared.
And what does that mean?
One side of the triangle.
What side is that?
The vertical side, or is it the horizontal side?
We can't say. It could be either, but there's another term that we can use to describe what A and B are. Could be horizontal, could be vertical, it depends. Yeah?
AC, if it's
So you said A and B are the what?
if you like on the triangle, the sides are like, but the longest side would be C.
What's the name of that one? Okay, we can jump over to that one.
I don't remember.
This is the hypotenuse.
That's the hypotenuse. And what's A and B? They're my,
Are those the legs?
those are the legs. One A could be vertical, A could be horizontal, it doesn't matter. But that's the Pythagorean theorem. A and B are the length of the legs, and C is the hypotenuse. So take that and fill it in for A. Take that and fill it in for B. And that will give you your distance formula. That's the length of the bottom side. Oops, and it's a circle. Oh. Let's circle that. Not that. That's it.
Thank you.
So fill in x2 minus x1 for A, y2 minus y1 for B. So let's look at our formula. There's the x2 minus x1 for A squared, y2 minus y1 for B squared. But why this square root? This was the formula somebody told me. There's no square root in that formula. Where's that square root coming from? Yeah?
You're squaring both of them, so you have to find the square root to get actual C instead of C squared.
Yeah, we want actual C. C is the hypotenuse, which is the length of the side that we really want to know. And we want C, not C squared. So that is how you get C. You have to take the square root of both sides. So the distance formula is just the Pythagorean theorem. All right, so let's use it to find the distance between these 2 points. And then we can talk about what can happen with the square root that we need to take care of. All right, let's go through and label what these are and where they're going to go in the formula. So Frankie, what's the 4? What's the 4? Out of these 4 different things I have to plug in, the x2, the x1, the y2, and the y1. What's my 4? Anyone help him out? I actually have 2 choices of what it could be. But once you tell me this, that's going to decide everything else in the problem. Colby?
X2.
Sure, we could call it x2. Now everything else has to be, it's automatic. What's the 5 now?
Y2.
That has to be y2. And that has to be x1 and y1. If you wanted to make the 4 x1, that would have been fine. But then the 5 would have had to be y1. All right, so let's fill those numbers in and see what we get. So it's going to be x2 minus x1. 4 minus 3. Let me square it. And y2 minus y1. In this case, James, what's y2?
5,
And y1?
2,
5 minus 2. And we square it. Lacey, 4 minus 3 gives me how much?
1.
And when you square 1?
1.
Good. And Jacob, 5 minus 2?
3,
Squared is
9.
9. So the distance between these 2 points is square root of 10. If the directions don't say to round it off to a decimal, you leave it just like that. If it said round to 2 decimal places, then on your calculator, you would have to type in square root of 10, which is about 3.16. This is what you call the exact answer, because it's not rounded. And for that one, there is nothing else to do. Square root of 10 is done. Any question on that one? All right, let's do one more distance one. And let's find the distance between the points 2, 6 and 4, 10. And this time, something different is going to happen. All right, so how about Jaden, could you tell me what's going to go in my first set of parentheses?
4 minus 2 and...
Yeah, that works. Yeah, and you're going to go ahead and tell me the second one?
10 minus 6.
4 minus 2, 10 minus 6. Perfect. 4 minus 2 gives me 2 to the second power. 10 minus 6 is 4 to the second power. Gives me 16. So now, get that. Square root of 20. Any questions on how I got square root of 20? I'm going to leave it like that for a second, but we're going to come back to that square root of 20 after I mention something. That square root of 20 can be reduced. And I don't mean rounded off to a decimal. Rounding off to a decimal, that's rounding off. That's not reducing it. So when we have square root of 20, it can be simplified. Now, there are different ways to do this. If you have a way that you know to do this and it works, just do it the way you already know how to do it. But if you don't know how to reduce a square root, I will show you one way that you can do it. This number underneath the 20, underneath the square root, that's called the radicand. It's the number under the root. One way to reduce it is to factor the radicand. Right? Factor means write as a product. Like if you write 10 is 5 times 2, you just factor. We have to factor the radicand, so it's the product of two numbers, and you want one of them to be a perfect square. What's a perfect square? James?
Number that can be put into a square root and come out with a whole number.
Yeah, a number that you take a square root of and you don't get a decimal as an answer. All right, so numbers like 4, 9, 16, these are all perfect squares. Can anyone think how you can write the number 20 as a product of two numbers, and I need one of them to be in that list? So yes, you could do 2 times 10, but that won't help. 2 is not in that list, and 10 is not in that list. Yeah,
4 and 5.
You can write it as 4 times 5, exactly. So to do step 2 on that problem, I'll show you what we're going to do. That's what you would do. Instead of having one square root with a single number, we're going to break it into 2 square roots with 2 numbers. And Aiden told me to do 4 times 5. So now you've broken it into 2 roots, and now something here simplifies. Anybody tell me which one of those simplifies? The square root of 4 or the square root of 5? Yep.
4.
Square root of 4 is how much?
2.
2. And that's how you simplify the square root of 20. It's 2 square roots of 5. Very easy to check if you did it right. Type in what you just got, type in what you started with. They should come out the same as a decimal. So that is a way you can check it if you want. Some people make like a tree to do this. If that works for you, you can go ahead and make a tree. But that's how I do it. Any question on that? All right, let's try one more of those before we look at the last thing. How about 48? Anyone think, how can I factor the number 48? Thinking of 2 numbers, and we want one of them to be in the list. Yeah?
4 and 12.
Okay, you can do 4 and 12. And what is the square root of 4?
2.
Good, 2. But now, does anyone notice anything about that square root of 12? Yeah, Jess?
You can break it down to 2 and 6.
Okay, is 2 or 6 in that list?
Or no.
So I agree, we can break it down.
Not 3 and 4.
We can break it down to 3 and 4. A hint here is if you have to break it down twice, then you didn't pick the biggest number that you could have out of that list. That's fine. It just means you have to do it twice. So if you break that down into square root of 4 times square root of 3, that 2 just hangs out in front. And you end up with 2 times 2 times the square root of 3. Perfectly fine to do it that way. But does anybody see another way that you can break down the number 48? But using a bigger number in that list than 4. Yeah.
16 and 3.
16 and 3. Probably not the one most people think of right away because it's not in the times tables. But you can break 48 down into 16 times 3. And the square root of 16 is 4. And you're done in that one step. Both methods are perfectly fine. All right, so that's the important thing I wanted to show you with square roots. Any question on that? All right, so the last thing is what we call the midpoint formula. So the midpoint formula doesn't tell you how far apart two things are. It gives you the location of a point in the middle. Think about if I had two numbers, like 2 test scores, and I want to know the one in the middle. Anyone remember what you usually call that? 2 test scores, I want the one in the middle. Yeah, Eden?
The median?
So yeah, that is one word you can use, the median. How about, think about like your grade for your report card. Usually if I had to give you a grade for your report card and we had those 2 test scores, I would take the 2 of them and do what? Dump?
Average.
I would average them. Okay? How do you average 2 things? What's the formula for averaging 2 things? Autumn?
Add them all together, then divide them by the original.
Add them together, and if we're averaging 2 things, what would we divide by? 2. So that is exactly what the midpoint formula is. It's an average. I don't know why it's doing that. It's an average and then another average. You take the x's, add them up and divide by 2. Gives me the averages for the x, and then take the y's and then add those up and divide by 2. So that's all that the midpoint formula is. It's actually a little easier than the distance formula because it doesn't involve square roots. All right, so we'll finish up by finding the midpoint of points A and B. Now remember, midpoint formula, the answer is not a single number. That's the distance formula. Midpoint formula is a coordinate. All right, so what do we get if we add the x's up and divide by 2? In other words, what's the average of 7 and 3? About John? 5. Okay. 7 plus 3, I'll write it out. Divide by 2, which as you just said is 5. And now we got to do 13 plus 4 divided by 2. So that's 17 divided by 2. You can leave it like that, that's fine. Or some people like the decimal. So what's 17 divided by 2, James?
8.5.
8.5. I would accept either 17 halves or 8.5 on a test. And that's the midpoint formula. Any questions on that? All right, perfect. So, for tonight, there are a few problems in the book, a few distance problems, a few midpoint problems I'd like you to try. And then I'd like you to simplify these 4 square roots. Remember, that doesn't mean find the decimal. Just simplify them the way I showed you. Were there any forms? Yes, the syllabus form. I'm going to count the syllabus form as a homework assignment as well, so if you get that submitted on Google, that's an automatic 100 for the first homework.